I want to take a closer look at correlation here to see if we can snuff out any bias in the data. So I've got some simple data here. It's just some fish data. Let's say it was pulled from two different locations. And the fish size is anywhere from a min of 17 pounds and a max of 88 pounds with the average of 56.5. And we've got fish type. We've got 3 different fish types. Okay. Fish ID is just the ID that was given. We don't know if it was in a particular order, just that it was tagged with that ID on it. Okay. Now, the first thing I like to do is run a correlation against all the variables. So let's see if we can run a correlation between fish type and fish size. Okay, so we'll do fish type, fish size, fish location, which I don't think we're going to need, but we'll see. So what we want to do is we actually want to put it over here, because what we're doing is we're building a plot or a matrix. And so this would always be a 1, right? A correlation between itself is a 1. So you would generally have 1s all the way down here. Okay, so now we're going to do the correlation of the fish type with the location. Okay, and now what we're going to do, and this is going to be where it's going to get a little goofy. We're going to do the fish size with the fish type, and I already know what you're thinking if you're looking ahead. Okay, as you're thinking that's going to end up being the same number. Absolutely, that's why it's called a matrix. So we've got correlation of fish size with location. Okay. And we've got the fish location, fish location with the fish type. Okay, and there's our 5 again. And now we've got the correlation of fish location to fish size. And there we go. So just to be fair, we'll pop these numbers out a little bit more, because there's a lot of 55s in here. They're not the same. These match up with this. These match up with this. Okay, good. Okay, so that is how you do a correlation plot or a matrix format as well. So what do I like to look at here? Well, I like to look at see if there's a strong relationship between anything in particular. And we've got a negative relationship here and a positive relationship over here. So fish type and location, we would say that there is a decent relationship there. So that's why it's important to study these things, because, you know, if there's a location and fish type relationship, then maybe that fish is plentiful there, right? If there's a negative relationship, then maybe it's not that common there. Okay. But what we're really after is we want to build a model that predicts the fish size. So we're really interested in the variables that predict fish size. And as it so happens, there's really the correlation between fish type and fish size. You know, it's a negative relationship. It doesn't mean that there is not a relationship. So negative does not mean no relationship. It means when one number goes up, the other number goes down. That's all it means, folks. When one number goes up, the other number goes down. Okay. So what number goes up and which number goes down? Well, if I look here, fish type 1 is 78, fish type 2 is 30, fish type 1 is 73, fish type 3 is 50. So I'm starting to see a pattern here. that the higher the fish type, the lower the weight. So there you go. As the fish type increases, the lower the weight. Okay. Now you have to ask yourself, have you ever heard of a fish type 1 or fish type 2, fish type 3? No, you haven't. So right off the bat, we might have some bias in how our model is developed. What that means is the way that we've constructed our file, there might be a natural bias and an interpretation to the file. So you have to be careful with those things. 1 could mean walleye, 2 could mean perch, 3 could mean sunfish. We don't know that necessarily, but our model does believe that there is some sort of a correlation to this. So just be careful with that, because you could introduce bias into your model. It's a case-by-case basis. You have to think about it. If I have 30 different fish types, I don't know if I'd be comfortable with going from 1 to 30. I might do a binary model where I take my variables from left to right with ones and zeros instead. Because a 1 to a 30, the difference between 1 and 30 is huge in a file like this. So I might want to restrict my variables to ones and zeros just to give that 30 an equal level of strength to that 1 out there. So let's go ahead and make a model here. It's a simple, or a multi-regression, but simple format here. We're just going to do go to data analysis pack, regression. Definitely keep track of what I typed down here, and let's talk about the bias there. So our input, what are we going to predict for? We're going to predict for fish size, and we're going to use, actually it might yell at me because I'm using it might yell at me here. Let's see if it does. I'll put range. Let's just put something right down here and hit OK. Yep, it's yelling at me here. Great example here of what we need to do is we need to move this variable over here to the right. Okay, and we're going to move this variable here. Actually, we're just going to redo this. Basically, it needs all of the x variables, the independent variables, next to each other. So we're just going to move fish type and location over here. It means nothing for a model. I just don't want to cut anything now that we've got these beautiful correlation plots. But we're going to solve for this, so it needs the independent variables next to each other. It's kind of silly, but that's what Excel needs. So make sure you still got your C11, and then this time, instead of doing the original stuff there, we're going to grab fish type and that, hit labels, and hit OK. And there's our model down here. Now our R-squared is 41. Our significance of F, though, it's 15%, and our p-values are horrible. Okay, so this is a great example, folks, of your R-squared could be around 50%, and we ideally want it to be 70. I mean, I've definitely seen R-squareds like 0.03 before. I mean, believe me, this is better. But we've got several problems here. The sample size, basically, over here is causing a lot of destruction with the data set, and we would expect that. We have 10 rows of data, right? So this might be a situation where we diagnose something. So I'm going to do an analysis of fish location. Okay. So I got 1, 2, 3, and I'm going to do number of fish. I'm going to do average size. Okay. Okay. And I'm going to do count if. Count if this equals, I'm going to click on the 1. Okay. And I need to absolute cell reference this stuff before I proceed. Oops, cancel that. I'm using a different computer, so it's I'm used to my Beast, a computer that just had all these extra gaming kind of buttons on them that I could easily just do things with. Okay, so there actually isn't a fish location 3 there, but then we got an even split. We got 5 and 5. Okay, now let's do an average if. Okay, so we're going to take the range of fish location. We're going to want the 1, and then we're going to do the average of the fish size. Okay, and we're going to absolute cell reference these. And in a minute, we'll change them slightly, but okay. So we definitely have some information here that's biased. So what I mean by that is there are other variables contributing to the relationship of other variables in the model. What I mean by that is clearly there's a weight difference. For example, there is for every 1 pound of fish in fish location 2, a fish in fish location 1 has 1.6 pounds. So naturally, that's influencing the model. Okay, so the fish location is influencing the model, possibly more so than the fish type. We don't know that yet, but that's what you got to think about here. So let's do another one here of fish type. And this is where we get our 1, 2, 3 number of fish as well. So we're going to do the same thing here. See if we can cheat a little bit by copying our formulas a little bit and then manipulating them. So fish type is the 1 this time. Okay. And there we go. Okay, except I made a mistake. We want to drag this one down too. I knew there was something else we had to do. Sometimes when you try to do things very fast or cheat, you cause more problems. So just be aware of that. Okay, there we go. Now we'll do the same over here. This time maybe we won't make the mistakes. So we still want fish size, but now we're breaking it down by fish type. We're going to drag this reference down here. And just make sure everything lines up. Fish type and fish size, perfect. So here's what we have. So we've got a couple of things here. First of all, this is why your p-values are bad, folks. You only have 2 fish from fish type 2 and 2 fish from fish type 3. So not a really good spread, not a well-fitted model. It might reflect reality, but it might also reflect that the person or the biology professor who was fishing that day had little luck, and they probably should have gone for 5 of each and made a 15 model, or just started with 1 type of fish or whatever it is. But these numbers here help you kind of start to break down and understand those p-values a little bit. Like now, if I were to take the average size of fish type against the lowest one, I've got a 3 difference. I've got a huge difference here. For every 1 pound of fish type 2, I've got 3 pounds of fish type 1. So you can start to see here the spread of how this works out, so that you can start to appreciate your data. I mean, this could easily be customers and quantity of food that they purchase, or plate size at a salad bar or buffet line, things like that, right? You could break it down that way. This could be age, like pre-adult, mid-age, and then elderly person, and you could break that down by number of plates, average size per plate, whatever it is, right? So that's really how you start to break this down nuts and bolts. And I really want to get you guys there. I don't want you guys to just stop at, okay, I'm hitting the data analysis pack. Okay, I got this. Okay, great. Turn in my homework assignment. Yay. Okay, that's fine. That's fine. You'll get your 5 out of 5 points. But, as you remember from my history, and this might be corny to share, I've traveled the 7 seas. I've gone everywhere in the world. I've gone, right now, Armenia and Uzbekistan are fighting. 2 countries you might not have ever heard of before. I've been to both countries. I've been there. They're beautiful places. They're fighting over a little scrap of land right now at the timing of this video. But my point is, you've got to strive for more. You've got to go beyond the requirements. I'm expecting that those of you particular BI majors, but those of you that took this class, I know some of you might have taken it because you enjoy it or you heard it's a good class. You know, even you, I'm talking to you here. Step out of that box, step out of your norm of just rush, get my homework assignment done, and just play. Just play with this data. Like play with it, like truly play around with it. You know, I mean, get your laptop when you're watching Netflix or whatever you're doing, just sitting on your couch, play around with it, putz around with it for a couple minutes here and there during commercial breaks or those required things on YouTube. Or, you know, when, you know, you just need a break from TV, just play around with this stuff. So, I mean, this speaks volumes to me. Poor sampling over here based on fish type. Over here, yeah, you got a nice setup here. You think, oh, nice sampling. Yeah, based on fish location, but there's only 2 fish locations. And then over here, naturally, this fish location has an average size that's a lot higher. So great descriptive statistics for you to think about as well.